Good day everyone, my name is Dares Christian Embulneo and I will be one of your reporters for today's lesson, which is all about the aggregates from the subject CENG60, construction and material testing. So aside from myself, the reporters for today also includes Ms. Joan Ciliada, Mr. Leomar L. Mangopot, Mr. Niel Berlin R. Punsalan, Mr. Joloshan A. Ramos, Ms. Janice T. Regis, and Ms. Kyla Jane T. Romanos. So before we proceed to our topic proper, let's first discuss the objectives of this talk. So basically, by the end of the discussion, you should be able to, number 1, understand what are the aggregates, its definition, classifications, and uses. Number 2, to know aggregate sources as well as its method of extraction and processing. Number 3, to identify mineral constituents in aggregates. Number 4, to learn what are the quality tests performed on aggregates based on its properties. And last but not the least, to learn how sieve analysis is used in aggregates. So basically, by the end of this lesson, we should be able to accomplish our purpose or the purpose of our discussion. So our topic for today includes the following. So number 1, we will be discussing what are aggregates. So i-discuss natin kung ano ang aggregates as a whole and bibigyan natin siya ng definition. Number 2, we will be discussing aggregates in construction. So kung ang number 1 is aggregates lang as a whole, ang number 2 naman is aggregates with connection or in terms of construction. Number 3, we will also be discussing aggregate sources. So sa madaling salita, kung saan nagmula ang aggregates. Number 4, the methods of extraction and processing. So itong mga sources na to, pag-aaralan din natin kung anong mga process ng extraction ang ginawa upang ang sources na to is mapunta or ma-turn into aggregates. Number 5, classification of aggregates based on shape and sizes. So ang aggregates pala ay hindi lang isa. So kina-classify din siya dahil marami siyang uri, pero nakabase sa shape and nakabase rin sa size. Number 6, mineral constituents in aggregate. So, i-discuss natin dito kung ano nga ba ang bumubuo sa isang aggregates. So, in number 7, we will be discussing the uses of aggregates. So, dito naman, ipapakita natin or bibigyan nating pansin kung ano nga ba ang gamit ng aggregates sa mga sumusunod. So, number 1, ano nga ba ang gamit ng aggregates sa concrete? Ano ba ang gamit ng aggregates sa asphalt and roadstone, sa mortar, and sa railway ballast? Number 8, we will be discussing the quality tests on aggregates. So, bago ito iproseso or bago ito gamitin para sa construction, meron munang mga test na ginagawa or testing ng kalidad ng aggregates upang masiguro natin ang tibay ng mga aggregates na to sa paggamit natin ito sa construction. So mamaya madidiscuss din natin yan, and last but not the least, the sieve analysis. So ngayon, alam ko na most of you ay marami pang katanungan sa isipan, pero later on with this discussion, little by little ay masasagot natin ang lahat ng inyong mga katanungan. So before we proceed to our topic proper, as a warm-up, here is a short video all about aggregates.
What is aggregate?
Well, aggregate is one of the 3 principal ingredients of concrete. It comes in different sizes and starting from sand and moving up to larger particles. And these particles fit together to produce a dense material. So in concrete, these pieces of aggregate are bound together by a mixture of cement and water to produce a material that is initially moldable and with time develops strength and becomes stiff.
What is cement?
Well, cement is the second principal ingredient of concrete. There are many types of cement. The one we use most widely is called ordinary Portland cement. The way that's made is to take 3 portions of limestone and 1 of clay, heat them to 1500 degrees centigrade in a kiln, grind that material down to a powder, the powder that we call cement. So if we take cement and mix it with water, we form a paste. And within the paste, chemical reactions occur. We call those hydration. And those result in the paste turning from a liquid into a solid material.
So what's the point of the aggregate?
That's a good question. The cement paste acts as a glue to hold the particles of aggregate together. Aggregate's just as strong as cement paste and is far less expensive, and so we use concrete rather than cement paste on its own. There are other reasons too why we don't use cement paste in construction. Cement paste expands and contracts as it heats and cools. It also expands and contracts as it wets and dries. The aggregate, which is more stable, reduces these effects.
Does the manufacture of concrete have a high carbon footprint?
Yes, it does. Cement manufacture involves heating the raw materials to a temperature of 1500 degrees C, which uses a lot of energy. Also, as the limestone is broken down in that process, it releases carbon dioxide, leaving calcium oxide. And that CO2 goes into the atmosphere and contributes to the carbon footprint of cement. But actually, that isn't the whole story. Concrete is a very energy efficient material when used in buildings, in the sense that it will store energy in the winter, and it will keep buildings cool in the summer. And so when viewed across the whole life of a building, concrete compares very favourably with other materials. But there are situations where energy efficiency is not of concern. And examples of that are foundations for buildings and the walls of a dam. But in those cases, alternative materials don't exist.
Now, let's proceed to number 1, which will answer the question, what are aggregates? So, ano nga ba ang aggregates? So, sabi rito, aggregates are particles of random shapes which can be found in nature as sand, gravel, stones, or rocks that can be crushed into particles. They may also be byproducts or waste materials from an industrial process or mining operation. So, sinasabi rito na ang term na aggregates are generally refers to mineral particles which have rock as their origin unless otherwise specified. Ang aggregate sizes vary from several inches to the size of the smallest grain of sand, and in special cases, aggregates larger than several inches may be used. So, particles smaller than the size of a grain of sand are considered as impurities even if they are of mineral composition. So now natapos na natin na i-discuss or i-define ang aggregates as a whole. Now, paliitin naman natin ang ating topic at mag-focus tayo sa aggregates with connection sa construction. Since ang ating course ay all about construction nga dahil tayo ay civil engineers. So sabi rito, the road building industry is the greatest consumer of aggregates. Aggregates are used as a basis or cushions between the soil and traffic wheels or between the soil and pavement, and are also used in bituminous pavement and Portland cement concrete pavement. They are used as leveling and supporting bases between the soil and all types of structures. They are used as ballast, which is the base of railroad tracks. They are also used as protective and decorative coatings on roofs and floors. Another major use of aggregates is to filter water. So, sinasabi lang rito na ang pinakamalaking ambag ng aggregates ay sa road building industry. So, yun, ang kumo-consume sa aggregates ay ang road building industry talaga. Dahil sa mga roads natin, before natin ilagay, for example, ang ating mga pavements or bago tayo maglagay ng mga semento sa ating mga daanan, ang aggregates ang ginagamit nating base, or after ng soil, yung aggregates mo nang ilalagay bago natin ikabit ang mga pavement and bago natin ilagay ang semento. So, bakit nga ba ito ang ginagamit natin? Sabi rito, nakakatulong nga daw ang aggregate sa pagle-level at pag-support ng base between the soil and all types of structures. So, with the use of aggregates, mas napapatibay natin ang mga road buildings na ating ginagawa at mas nale-level natin, at ang outcome na nabubuo natin sa mga roads natin is mas maganda compared to the road buildings na walang aggregates, which is not recommended nga din. So aside from being a base, ginagamit din siya as a decorative coating sa ating mga roofs. So kung makikita nyo yung mga bubong ng mga mayayaman, yung mga pa-rainbow type na parang makikita nyo lang sa mga hacienda, hindi po yun gawa sa yero. Ang mga tunay na bubong na ganun ay gawa sa aggregates or sa mga maliliit na particles na mga sand, mga soil, mga rocks. And kine-curve lang siya upang makabuo ng rainbow pattern. And pag pinagsama-sama yun, nakakabuo siya ng magandang image na ginagamit nga as a decoration sa ating roofs. So aside from the roof and aside from being a base in railroad and in road building industry nga, ginagamit din siya as one of filters of water. So, alam naman natin kung gaano kahalaga ang ating tubig. So, ang aggregates ang isa sa mga levels na nag-filter sa ating water upang ma-convert siya into, for example, is drinking water. And we all know how important drinking water is. So, kung i-compare mo ang food sa water, water ang more essential than food kasi mas mabubuhay nga tayo ng mas matagal if may tubig tayo, unlike if ang meron lang tayo ay food. So, in continuation, there's not always a clear distinction between aggregate and the engineering material, soil, which also comes originally from rock. Some naturally occurring sand and gravel soils are usable as aggregates without processing. Most aggregate is soil that has been processed. Soil which remains in place and serves as the ultimate foundation of all construction is not considered as aggregate. So, sa madaling salita, ito na lang ang sasabihin ko. Aggregate cannot be always soil, but soil can be aggregate. So, balik rin natin. Soil can be aggregate, but aggregate cannot be always a soil. So, sinasabi rito na sometimes daw or most of the time, nagkakaroon ng kalituhan sa differences ng soil sa aggregates. Pero yun nga lang ang tatandaan natin na ang soil is pwedeng i-process para mag-turn into aggregates, but yung aggregates cannot be always soil. So, merong mga other materials or other sources ng aggregates na hindi related sa soil pero kayang mag-produce ng aggregates through extraction and other types of processing.
So now we will go to the classifications of aggregates. So first classification is based on their shapes. First is rounded. So rounded aggregates are natural aggregates watered by weathering, erosion, and attrition. Rocks, stones, sand, and gravel found in riverbeds are most common rounded aggregates. Rounded aggregates are the main factor behind workability. So as we can see here in the image, we can see a rounded aggregate. So as you can see here, it is smooth and most commonly makikita natin siya as a area sa mga riverside. So kung saan mas na-work siya, nagkakaroon siya ng pang-weathering and erosion. So mas napaprasya siya doon and Ito yung kadalasan ginagamit ng mga lolo natin sa panghilod. Kung nakita na kayo ng panghilod, so that's a perfect example of a rounded aggregate. So next is irregular. So irregular aggregates these are also shaped by accretion but are not fully rounded. So this consists of small stones and gravel and offer reduced workability to rounded aggregates. So compared sa rounded aggregates, itong mga irregular aggregates na nakikita natin sa images sa nakikita natin smooth din sila and they bring through the same weathering, accretion, and erosion as rounded aggregates, but the product is different, very different, no? So you can see here na iba yung kanilang laki, and these have corners compared to rounded aggregates. So we can have mga pan-design sa walls and etc. No? So the next thing natin is the angular aggregates. Angular aggregates are used for higher strength concrete and aggregates come in the form of crushed rocks and stone. Workability is low, but it can be offset by filling voids and be found and consumed. So here is an image of angular aggregates. So kung nakita nyo na ito, siguro nakita nyo na ito dati sa kapag sa mga sa sites, construction sites, no? Kasi sabi dito is used for higher strength concrete, no? Parang mas bagay siya using from concrete, no? Ito naman hindi siya nanggaling sa weathering, erosion and accretion, unlike the two others in regular and the rounded aggregates. So here on angular aggregates, it is from rocks and stones that have been through rock quarrying. Since earlier na-discuss natin about sa rock quarrying, it comes from the mountain sides, yung tayo nag-rock quarrying. These are some of the aggregates that the products of those quarrying. So next is the flaky aggregates. So flaky is defined as aggregates that are thin in comparison to the aggregate. So it increases surface area to maintain concrete mix. So ito naman is the flaky aggregate. So katulad ng angular, madalas na nakukuha natin siya sa rock quarrying din, and nagagamit din siya sa concrete mixing. So the advantage of this aggregate is, as said here, it increases the surface area. So mas marami pang malalagay na mga ganito klase aggregates sa concrete mixing. So compared sa angular, no? Pero yun nga, so mas malaki yung nakukuha ng space. So next naman natin is the elongated aggregates. So elongated aggregates adds more surface area to a mix, concrete mix, so meaning more cement spaces. So elongated aggregates are longer than they are thick or fine. So here images natin ng elongated aggregates is almost same siya ng flick aggregates na nag-aagawin surface area space. So ito nga yung sa angular aggregates, mas mahaba siya, no? So you can see here, pinulita natin kanina, itong flaky aggregates natin, it is very thin but it is not long. Okay, so dito naman sa elongated natin, it is long but it is not thin. So the next is flaky and elongated. So ang mix of yung dalawa, yung flaky and elongated natin as the main class. So and the least, ito yung least efficient form natin ng aggregates with regards to workability. So as you can see here sa images natin, it is long and thin. So not very workable, and again sa surface area natin sa mixing, and it's very thin, that's so and that are the classifications of aggregates based on shape. Now we are going to classifications of aggregates based on their sizes. So first is the fine aggregates. So when the aggregates natin is saved or processed to 4.75mm sieve, the aggregates passed through it called the fine aggregates. So natural sand is generally used as a fine aggregate. Silt and clay also comes well. So the salt deposit consisting of sand, silt, and clay is termed as loam. So the purpose of the fine aggregates is to turn the boards into coarse aggregates and to act as a workability agent. So the mga fine aggregates na natin is the thinner or the small aggregates na makaklasify daw natin as sands and silt and clay. So hindi naman dito na silang ginagamit to fill voids. And so here is a table of fine aggregates natin. So first, and there size variation. So first we have the coarse sand, which have a size of 2.0mm to 0.5mm. So yung medium sand naman, so it mas malalim pa na 0.5mm to 0.25mm. So mas maliit pa siya pa. So mas maliit pa natin doon is the fine sand is 0.25mm to 0.06mm in size. So next is the silt or 0.06mm to 0.002mm in size. So yung final classification natin ng fine aggregates is the clay, which the size is lower than 0.002. So siya yung pinakamaliliit na kapag ang fine aggregate is very small, it can be classified as the clay. So that five are common classifications of the fine aggregates when it comes to the sizes. So next thing natin, there's our sizes. Aggregates. So when the aggregate is saved for a 4.75mm sieve, the aggregates within retained is called coarse aggregates. So gravel, cobble, and boulders ang aggregates ignored. So the maximum size aggregate used may be dependent upon some conditions. So in general, 40mm size aggregates used for normal strengths and 20mm sizes is used for hollow smooth concrete. So the size range of various coarse aggregates given later on the table. So first, sisix po natin what is coarse aggregates. So sabi dito, the aggregates natin they went through the same sieving process which will be deceived to 4.75mm sieve. So pareho lang nagdaan yung aggregate sa fine aggregates. Yung coarse aggregates, yung mga natirang aggregates natin na hindi nag-pass through sa sieve natin, sa sieving natin, sila na yung matatawag ng coarse aggregates. So meaning these aggregates are bigger on size compared to the fine aggregates. And most examples of coarse aggregates are gravel, cobble, and boulders na sila yung mga nagpo-fall under sa category nito. So maximum sizes ng aggregates natin sa na ginagamit namin sa mga construction natin is the 40mm size and 20mm size. Where a 40mm size aggregates natin or coarse aggregates natin used for common streets sa concrete natin. So while yung 20mm size naman natin ay mas nagagamit siya for high use strength concrete. So ito yung table natin ang mga coarse aggregates. So first is the fine gravel. Variation natin. So variation natin siya ay 4mm to 50mm in size. So medium gravel naman natin 8mm to 16mm in size. So mas malaki siya. So coarse gravel natin sila yung ginagamit mas commonly on constructions. So as given here sa kanila na ito 4mm20 and 40mm na madalas na ginagamit sa construction natin, which is 16mm to 64mm in size. So cobbles is 64mm to 256mm. kanilang size and boulders naman natin is boulders are very large, so greater than 256 millimeters constitutes boulders. So those are the methods of extractions and processes and the classifications of aggregates based on their shapes and sizes. So we will now proceed to the next report.
And now, speaking of sources, let's move on to the next lesson, which is all about the sources of aggregates that will be discussed by Ms. Joanne Liada.
After the discussion about the classification of aggregates based on shape and classification based on size, we will now proceed to the discussion about sources of aggregates. So, aggregates can only either be natural or recycled. Aggregates can only either be natural or recycled. But now, let's first discuss natural aggregates. The Earth's crust is solid rock called bedrock. As much of crust is covered with soil particles originally derived from bedrock. This soil is classified according to size as gravel, sand, silt, and clay, with gravel being the largest and clay the smallest. Natural aggregates include sand, gravel or larger stones, and bedrock reduced to particle size by manufacturing methods. So as mentioned, soil particles, which is at top of the bedrock, originally derived from bedrock, or originally it is part of the bedrock. It is the outermost part of the bedrock, which is through time has been scraped off or has been removed, and it became soil particles. And soil particles, it contains the aggregates. So technically, aggregates are originally came from bedrock. It only came to different forms, such as it became gravel aggregates, it became sand aggregates, or it became silt or clay aggregates. The factors that affect how they come up with their being sand or being gravel, there are a lot of factors, like for example, weathering or erosion or any other natural processes. To visualize the aggregates, here are some pictures. This is what gravel aggregate looks like. This is sand aggregates. This is silt aggregates, and lastly, this is the clay aggregates. In our country, in the Philippines, here in the Philippines, we are most familiar with the gravel aggregates. In Tagalog, it is called graba. We usually see gravel aggregates used in concrete mix. But however, of course, it can also be used in other construction, such as road construction, but it is another topic which will be discussed later on by another reporter. From the name itself, natural aggregates, these aggregates are naturally occurring, and it only undergo physical processing. For example, aggregates are crushed or by crushing. And again, aggregates are reduced by its size because basically different constructions require different sizes of aggregates, or it has standard sizes of aggregates that they use. So this is what natural aggregates are, and the most commonly used aggregates in construction are gravel aggregates and sand aggregates. So as I said, aggregates originally came from bedrock, but of course, to be exact, sources of natural aggregates are generally sand and gravel pit and quarry. So this is what sand and gravel pit looks like, and on the other hand, on the right side is the quarry. The difference between the two is that in sand and gravel pit, aggregates are located underneath the surface, while on the quarry, aggregates are located directly at the surface. For this reason, in sand and gravel pit, to collect the aggregates, it usually undergo mining. On the other hand, on quarry, since aggregates are on the surface, it does not need mining. Aggregates can be digged directly at the surface. Though the methods of how exactly aggregates are extracted is another topic which will be discussed further. For now, we need to understand what the difference between the sand and gravel pit and quarry, which is these two is the most or generally sources of natural aggregates. As I said, aggregates can only be either natural or recycled. And since we are done discussing natural aggregates, let's now talk about recycled aggregates. The term recycled aggregates refers to the reprocessed materials that have previously been used in construction. Reprocessing involves activities such as crushing, mixing, or grading aggregate to meet the required specifications. So when we say recycled aggregates, these are aggregates that are already been used. The idea of recycled aggregates came along with the idea of conserving our natural resources. So as you can see in the picture, there are concrete debris. These concrete debris can possibly came from demolished buildings or demolished house. So these concrete debris will be reprocessed to be used again as aggregates, and it will be called as recycled aggregates. So if instead of natural aggregates we use recycled aggregates, what are the benefits? So first, being it is recycled, using recycled aggregates is eco-friendly. Using recycled aggregates reduces the amount of the use of natural aggregates, which also mean less use of natural resources, because as we all know, natural aggregates aggregates is natural resources. Number two, or the second benefit of using recycled aggregates is cost saving. Producing recycled aggregate is more cost effective than producing natural aggregates, because in producing natural aggregates, there is a transportation cost, equipment cost, and it will consume a lot of time, and as we all know, time is money. Overall, it will cost more using natural aggregate than using recycled. And the last benefit of using recycled aggregates is sustainability. Sustainability is just somehow linked with eco-friendly. It has something to do with the less use of natural resources. So, before finally approving the use of a recycled aggregates in a construction, it needs to meet the required specifications. After the processing, it will undergo testing, and it should meet the standards. If by any chance it does not meet the required specifications, sadly it cannot be used as aggregates, or it cannot be used in construction. But however, the process of producing recycled aggregates is intricate, and it ensures that it will meet the required specifications. So that's it. Recycled aggregates is simply the aggregates that are already been used, and they are the ones who will undergo reprocessing and will be used again. So as we are already done with discussing the aggregate sources, and we already know the two general sources of aggregates, the sand and gravel pit and the quarry, we will now proceed in discussing the evaluation of aggregate sources. Civil engineers select aggregates for their ability to meet specific project requirements. The physical and chemical properties of the rocks determine the acceptability of an aggregate source for a construction project. These characteristics vary within a quarry or gravel pit, making it necessary to sample and test the materials continually as the aggregates are being produced. So it simply means that in evaluating the aggregate source, for example, a quarry, in evaluating it, the physical and chemical properties of rocks there are taken into consideration. So samples of rocks will be collected, and it will be examined, and by gathering the information needed, it will determine whether the aggregate source is acceptable to be an aggregate source for a construction project. So if the aggregate source, for example a quarry, is already been agreed, or it is already been accepted to be a aggregate source, the need to sample and test the materials as the aggregates are being produced is still necessary. Because as the aggregates are being produced, it needs to ensure that the aggregates will meet the specific project requirements. So it will be tested as the process is happening or as the process goes on. Due to the quantity of aggregates required for a typical project, the cost and availability of the aggregates are important when selecting an aggregate source. Frequently, one of the primary challenges facing by an engineer on a project is how to use the locally available material in the most cost-efficient manner. So, as mentioned earlier, in selecting aggregate source, it needs to meet the specific project requirements. And these project requirements, it includes quantity of aggregates, the quality of aggregates, the cost that will be spent, and lastly the availability. And one of the problem of engineer that on a project is how to use the locally available material. It needs to assess the materials that are available locally, and it needs to be maximized to be used in a cost-efficient manner.
Potential aggregate sources are usually evaluated for quality of the larger pieces, the nature and amount of fine material, and the gradation of the aggregate. The extent and quality of rock in the quarry is usually investigated by drilling cores and performing trial blasts or shots. From the previous slide, we have learned that in evaluating aggregate sources, the rocks on site are the ones that are being examined. And that examination will determine whether the aggregate source will meet the required specification of a certain project. And samples that are collected, or the rocks that are collected, are mostly in large sizes, because the quality of larger sizes will determine the overall acceptability of aggregate source, whether if that potential aggregate source is suitable and can meet the requirements of the project. Specifically, in quarry, rocks are examined by drilling cores and performing trial blast. The picture on the upper right is the illustrations, or are the illustrations. The one on the left side was drilled, while the other one on the right side undergo trial blast, or you can simply call it shots. Rocks need to be in larger pieces to make the examination much easier. For example, you can see in the picture, in performing trial blast, it will even make the sample reduce in size. So, it is necessary that initially, it is in larger sizes, or the rock are in larger size.
Cores are examined petrographically for general quality, suitability for various uses, and amount of deleterious materials. Potential sand and gravel pits are evaluated by collecting samples. The amount of large gravel and cobble sizes determines the need for crushing, while the amount of fine material determines the need for washing. Petrographic examinations evaluate the nature of aggregate particles and the amount of deleterious material. Price and availability are universal criteria that apply to all uses of aggregates. However, the required aggregate characteristics depend on how they will be used in the structure. Cores are examined petrographically. Petrographically simply means study of rocks in detailed descriptions. Quality of rocks are carefully examined. If majority of rocks are large in sizes, then it determines the need of crushing. And there are equipments that are specifically suitable for this. On the other hand, if majority are fine materials, then it determines the need of washing, or simply the unnecessary materials are removed. One of these, which was mentioned earlier in the discussion, are impurities, and there are also equipment suitable for this case. So, the availability of equipment is also a factor to consider in selecting aggregate source. Nevertheless, after all, the important is that it should meet the requirements in a project. Before proceeding to another topic, let's first have a short recap about the topic aggregate sources. So we have learned that aggregates can either be natural or recycled. Natural aggregates are those gravel, sand, and others, while recycled aggregates are simply natural aggregates that are already been used and will be reprocessed to be used again as aggregate. And after that, we discuss the sources of natural aggregates, which are sand and gravel pit and quarry. And lastly, we have discussed how these natural aggregate sources are evaluated.
So, good morning everyone. I'm Yoberly Alfonsalan, and I'm going to report about the methods of extraction and processes of aggregates. And also the classifications of aggregates based on their shapes and sizes. So first natin is the processing. So during processing, aggregates are distilled down to a level of their most common use. So some aggregates may be crushed to a powder, while others may be screened to various diameter chunks. So sa processing daw natin, gagawin daw natin sa processing is kukuha tayo ng aggregates, we will have it processed and worked to make it on their respective sizes and shapes that will be used for construction purposes or other purposes. So, first natin sa processing is quarrying. So, quarrying is a large deposit of desirable aggregates is identified and extracted from the ground. So, mostly, ang quarrying po natin is nagagamit siya on nangyayari siya on mountain sides or sea or on the sea or ocean. So paano natin nakunin sa ocean? So later on, mag-discuss natin kung paano ba tayo kumukuha ng aggregates on ocean floor, and kung paano ba tayo kumukuha ng aggregates naman on the on mountains or mountain sides or other places, quarrying locations. So next natin sa processing is feeding through a crusher. So earlier nabanggit natin yung pagpaprocess, but here nangyayari siya dito sa feeding through crusher through reducing the size of quarried rubbles down to chunks 6 inches in circumference or other sizes. So the product from the primary crusher is then screened for large reusable products. So sabi nga kanina, may processing tayo na tinatawag pa after natin makuha through quarrying yung mga nakuha natin aggregates. So dadaan siya to crusher or other processing pa. So kung saan pinapaliit pa nila yung mga nakuha nating aggregates through specific sizes nga. Yung specific sizes kung saan sila mas suitable or kung saan sila mas magagamit for construction process or other so on processing naman natin, what is the importance of processing? So on maintaining the desirable qualities natin, which is between 60 to 75% of concrete, kasi sila yung bakit natin kailangan ng maintaining yung desirable qualities. So kasi ang concrete natin will be consisted of 60 to 75% both coarse and fine aggregates. So mostly na ating concrete na pag on mixing sa ating concrete, most of it is most of the materials we will be using is from the aggregate. So sila yung mas common when it comes to mixing concrete. So kaya kailangan natin ma-maintain yung desirable quantities nila. If not, it could cause structural failure kung hindi tama yung pag-process natin ng ating aggregates. So yung aggregates natin na if they are not properly sized, not properly cleaned, and not properly free from other matter, it can lead to structural failure. So yung sa properly sized naman is pwede pa siyang mag-vary. So minsan kapag hindi tama yung nagamit ng size na aggregate sa pag-mix mo ng concrete natin dyan, sa pag-mix mo sa kanya sa concrete, pwede naman siyang matignan. So it will come down to the person who process the aggregates. So it's not properly cleaned, so baka mamaya meron ka ng may nasama ka ng mga basura pala doon sa aggregates, especially on those aggregates or na like sands, yung mga finer aggregates natin dyan. Kapag hindi mo sila nalinis, so maybe hindi na napansin na meron na palang basura or other things, other matters na doon sa ating aggregates, it could lead to structural failure. So yeah. So next naman natin, we will go to the methods of extraction. So here we go. So first method of extraction natin is rock quarrying or crushing. So this is when powerful hammers or metal jaws within the primary crusher breaks the rock down. So rock passes through a series of screens that sift it into different sizes. So kanina, sabi natin na feeding to a crusher, no? So here sa rock quarrying, siya ay most common siya dito kasi this rock quarrying mostly happens on mountain sides, wherein binablast through natin or minsan sila nagpapasabog tayo ng mountain sides. So syempre yung mga mountains naman na pinipili natin na it is safe, no? So as we can see here sa image, yung mountain natin dito or hill, you can call it here, mountains, no? Kung saan tayo nagkukwari ng mga rocks, it is not very large mountains. So hindi siya magkakos ng landslides or whatsoever na makaka-affect sa life or could lead to danger. So pinipili yan ng maayos kung saan tayo pwedeng mag-rock quarry, no? Kung saan maganda yung mga rocks na makuha natin and stones or rocks, no? So as we can see here in the images, so sa may banda dito, makikita natin siya yung nag-breakdown ng ating rocks for rock quarrying. And meron tayo dito mga trucks na kung saan sila yung magdi-deliver naman ng ating mga na-collect na mga rocks or stones. So itong mga rocks na to naman is dadalhin sa isang facility, pwedeng dito na din sa kung saan tayo nagkukwari or nagbabasag ng mga bato, pwedeng dyan na din nila pinaprocess or pwede nilang dalhin sa isa pang facilities kung saan mas napaprocess pa nila ng maayos yung mga rocks. So next natin na quarry natin, our methods of extraction is the sand and gravel quarry. So compared sa rock quarry, it's much shallower than rock quarries and are usually covered and restored in progressive phases. So rock quarries are found to allow them to be worked dry or operated as digs with extraction below water. So yung extraction below water, natin pag-uusapan yan. So next natin pag-uusapan. So first natin is, it is different from the rock quarries. So kanina sinabi natin the rock quarries fast strike crusher, so it will be worked down. So yung sand and gravel quarry naman natin, so yung mga sand natin, it will usually work and restored in progressive phases. So what does it mean? So mas maraming processing ang ginagawa natin sa sand and gravel quarry, kasi nga mas maliliit sila. Kailangan natin ng mas finer na aggregates na makukuha natin dyan. Kaya mas napaprocess sila, mas marami silang pinagdadaan ng process para ma-attain nila yung certain sizes na minsan sila mapaprocess na maayos. So yun yung sa sand and gravel quarry. So next naman natin is the marine aggregates. So marine aggregates natin, marine aggregates or marine quarrying. So yung dito, so this is not very familiar to others kasi medyo different siya, kasi hindi siya nangyayari sa land area. So dito sa marine quarrying or marine aggregates, so satellite navigations will be used to position vessels precisely within licensed dredging areas. So yung vessel trail natin are parked along the marine floor at speeds approaching to 1.5 knots, and these powerful suctions pumps to throw sand and gravel into cargo hold. So dredge materials is discharged at wharves and other marine facilities where it is processed, screened, and washed as required. So dito daw sa atin sa marine quarry natin, marine gates natin na nakuha natin, may ginagamit tayong satellite navigation kung saan doon lang tayo sa isang specific location na makakakuha ng mga aggregates natin. So syempre hindi naman tayo pwedeng kumuha na lang basta-basta doon sa isang lugar. So let's say nagpunta ako sa Scarborough, so doon ako kumuha ng final aggregates. So syempre hindi pwede doon. So it can affect aquatic life and mga corals natin doon. So pipili lang tayo, no, ng mga areas kung saan tayo pwedeng kumuha or mag-extract ng aggregates natin. So meron naman tayong mga license natin. So mga vessels natin or cargoes natin, it will have a pipe or large pipe kung saan ito yung ginagamit natin para makapag-extract tayo ng aggregates on ocean floors, no? So yun. And then yung mga nakuha naman natin mga marine aggregates is it will go to a facility, no? Marine facilities, and where it will be processed, no? And papatuyuin, syempre kailangan natin yung aggregates para hindi naman mahirap, no? So here are some images of marine aggregates. Pag-extract natin ng marine aggregates or marine quarry. So on the left natin, so this is the extraction process of the marine aggregates. So as we can see here, there's a pipe na dito. Ito banda yung pipe. Diyan kung saan napapass through yung ating marine aggregates and pupunta sila doon, sa ating cargo o sa ating vessel. While on the right side naman natin, we can see here the processing na ang ating marine aggregates. So ito na sila pinapatuyo and then papass through sila sa same process din at dadaanan ng ating sand and gravel quarry kung saan pinafine nagpa-fine pa natin yung ating mga marine aggregates, no? Para ma-ensure natin na wala nang masasamang mga matters or other materials doon sa ating aggregates. Sabi natin kanina, proper processing ng aggregates natin. So, para hindi siya mag-lead to construction failure. So, that's the end of the material or the methods of extraction and processes.
In this report, we will be tackling about the uses of aggregates. As a basic raw material, aggregates can be put to many uses, though certain tasks may require specific type of aggregates. So in this report, we will be focusing on the uses of aggregates first in construction or using aggregates in building something, in concrete mixture, a mixture consisting of aggregates, cement, and water, in construction of asphalt and road stones, which includes pavements, airports, runways, parks, playgrounds, and other similar structures, in mortar mixture consisting of sand, cement, and water, and lastly in railway ballasts, which consists of granites. In this chart, we will see where aggregates go. The largest portion of aggregates, approximately 36%, goes to the manufacture of concrete, while another 10% is used to manufacture cement, which is also used in concrete. The 25% of aggregates is used for road constructions, and another 20% for other construction uses and fills. Railway ballasts consume 2% of all the aggregates, while the remaining 6% is used to manufacture other products such as glass, mortar, and use in agriculture. Let's start with the first one, the usage of aggregates in construction. Aggregates have many uses in construction, and one of these is to provide drainage, because water will percolate through a trench filled with aggregates more quickly than it will in the surrounding soil, thus enabling the area to be drained of surface water. And this technique is frequently used alongside roads in order to disperse water collected from the asphalt surfacing. And second is to fill voids. Voids created around the foundations of buildings during construction are filled with aggregate because it is easier to compact than the original soil that was removed. So this results to a more solid finish that will support the structure. And aggregates generally are not that affected by the weather as much as soils, particularly clay soils, so it will not suffer from shrinkage, cracking during dry spells. And next is to protect pipes. Pipes laid to convey treated water or as conduits for cables needed to be protected from sharp objects on the ground. So aggregates are laid on before the trenchers are backfilled. And the last one is to provide hard surfaces. Unpaved roads and parking areas are covered in a surface layer of aggregates to provide a more solid surface for vehicles from cycles to lorries. So this prevents the vehicles from sinking into the soil, particularly during wet weather. Aggregates, they are also used in water filtration and sewage treatment processes. Groundwater is filtered naturally through aquifers. These are often layers of sand and gravel, and this only needs to be disinfected with chlorine before it is ready to use. This natural process can be replicated in treatment works to remove suspended solids from surface or stored water. So this goes before disinfection. In addition, sand beds are used during the last stages of sewage treatment works as a final filter and cleaning process before the water is released into the water courses. In some cases, reed beds are used at this stage, and this is where the reeds will be grown on gravel. The next one holds the largest consumption of the aggregates. As said in the previous slide, it consumes 36% or around 36% of all the aggregates. So this is the concrete. Concrete has been used in some manners since the Roman times, and it is the most universal construction material. So this may be supplied in one of the two main forms. One of these forms is precast, or the blocks, tiles, and pipes. The second one is the ready mixed, or as a liquid paste ready for pouring. So aggregates in concrete is primarily used to provide a rigid skeletal structure. Both coarse aggregates, or the aggregates with a bit large particles sizing 20 millimeters to 40 millimeters, and fine aggregates, those that are less than 4 millimeters, are required, but proportions of different sizes of coarse aggregate will vary depending on the particular mix required for each individual end use. And aggregates in concretes are also used to reduce the space to be taken, or the space to be occupied by the cement paste. The smaller the aggregate size, the greater its surface area, so the more cement paste that will be needed to bind it all together. This will result in a higher cost, but however, in general terms, the greater the quantity of cement, the stronger the concrete will be. So there should be a balance between the strength requirements of the end use and the price that the customer will be willing to pay. Aggregates are also often used in conjunction with other structural materials such as steel or bricks. So it is also used as foundations, walls, floors, roofs, and partitions of buildings, as well as bridges, dams, power stations, and many other kinds of physical structures. By controlling and modifying the proportions of basic constituents, concrete is also highly adaptable, and a wide variety of specialist concretes have been developed for particular uses. Let's now proceed with the asphalt and road stones. Although some type of structure will require a specific or some variation in the material, it is useful to look at the basic structure of roads because they represent the bulk of aggregate used in this category. And let's start with the subgrade. Subgrade represents the natural soil, and the natural soil shall first be compacted before the construction of the road starts. And in case the strength of the soil is not enough, or if it is not coated with bitumen, a capping layer is an option to give the soil an extra strength. There is also the subbase, which is the main uncoated roadstone layer. So its role is to give strength and act as a solid platform for the layers above. We also have our binder cores and surface cores, commonly called as asphalt or tarmacadam, but we will be talking about it later on. And they consist of coarse aggregates with particle sizes typically between 2 mm up to 28 mm, and fine aggregates which are obviously lesser in size than 2 mm. So these aggregates will be mixed with bitumen binder, and occasionally, if required, some additional filler. And the exact sizes required for coarse aggregates will depend on the particular use and the asphalt recipe specified. Now, here's the layers that we discussed in the previous slide. As we may recall, there is the compacted subgrade, the sub-base course, and above it is the base course. I mentioned a while ago the binder course and the surface course, and now we will be talking about them. The binder course is the main load-bearing layer and provides an even plane for the surface course. Surface course, on the other hand, provides the road with protection from the weather because water ingress would be very destructive. And this also provides a final running surface that is resistant to abrasion and skidding. Increasingly, mixes are being developed, and these are known as thin surfacing or stone mastic asphalt, which uses cellulose fibers or specialist binders to obtain higher strength with thin layers of asphalt. So the main goal of this development is to provide increased resistance to deformation where traffic density is high, and to reduce surface water spray and vehicle noise. Now we'll be tackling about the fourth one, the mortar. In the introduction, I've mentioned that mortar consists of cement, water, and sand. But in some circumstances, lime may also be added to the mixture together with the chemicals to control setting and workability and or pigments if required, also known as the admixtures. This mortar mixture is used to bond bricks or concrete blocks used in walls to provide weather protection or rendering. But there are also type of mortar that can be used as internal plasters, though they should not be confused with the usually used gypsum-based plasters. Lastly, the railway ballast. As we may recall in the pie chart, in the first part of my report, the railway ballast has the least consumption of aggregates. It is around 2% of aggregates only. But aggregates are highly significant in railway ballasts. Imagine a fully loaded train weighing over 2,000 tons, and added to this weight is the weight of the track itself and the sleepers it rests on. So imagine how heavy it is. It obviously needs a very tough rock to support this weight and distribute the load of a passing train. This is to avoid serious damage to the ground or the structures underneath. Similarly, a railway track must hold the sleepers and the train firmly in place and not to move as it passes along them. So this is the reason why railway ballast is generally consist of igneous rock, tough igneous rock such as granite with large angular pieces which are 40 to 50 millimeters in size that lock together. Because igneous rock does not break easily due to it being formed as a highly resistant to pressure. So that ends my report, and thank you for listening.
Good day everyone, my name is Carla J.T. Romanas and I am assigned to discuss the quality test on aggregates ASTM reference. So before I proceed to the next slide, let me first discuss why we need to test aggregate. As we all know, or maybe some of us know, aggregate is one of the primary building materials and components of concrete. We test aggregates not just to know how strong and durable they can be, but also to ensure the quality of aggregates and check the properties of them. When I say properties of aggregates, I am talking about strength, toughness, hardness, shape, and water absorption. So next, for the first test method, ASTM C136 test method for sieve analysis of fine and coarse aggregates. So this test method covers the determination of the particle size distribution of fine and coarse aggregates by sieving. When analyzing materials, sieve analysis on aggregate is important because the particle size distribution can affect a wide range of properties such as the strength of concrete, the solubility of mixture, the surface area properties, and so on. For the procedure, I will present a short video clip for us to be more familiar with this method.
Today, we're going to demonstrate the dry sieving test method used to determine the particle size distribution of fine and coarse aggregates in accordance with ASTM C136, where a sample of dry aggregate of a known mass is separated through a series of sieves with progressively smaller openings to determine the particle size distribution of the test sample. The standard test method for sieve analysis of fine and coarse aggregates is used primarily to determine the grading of materials proposed for use as aggregates, and to determine the compliance of particle size distribution where applicable specifications are required, and to provide necessary data for quality control of production of various aggregate products and mixtures containing aggregates. Devices required for this test method are a balance or scale used in testing of fine and coarse aggregates with a readability of 0.1 grams for fine aggregate and 0.5 grams for coarse aggregate or mixture of fine and coarse aggregates. Test sieves that conform to ASTM E11 specifications. A mechanical sieving device to create motion of the particles to bounce, tumble, or otherwise turn as to present different orientations to the sieving surface. An oven of appropriate size capable of maintaining a uniform temperature of 110 degrees Celsius. A sieve brush, a sample container or pan, a sieve pan, a sieve stack cover, and a way to record and analyze your test findings. It is important to limit the quantity of test materials on any given sieve so that all particles have the opportunity to reach the sieve openings a number of times during sieving operations. For this demonstration, the bulk sample has already been reduced to an amount suitable for testing using the applicable procedures described in ASTM C702. The procedure for standard test method for sieve analysis of fine and coarse aggregates, we first dry the test sample in an oven at a constant temperature of 110 degrees Celsius. Measure on a balance or scale the tare weight or unladen weight of your sample container or pan. Now place the test sample into the sample container and measure its gross weight. Next, select test sieves with suitable openings to furnish enough information required by the specifications covering the material being tested. Nest the sieves in order of decreasing size openings from top to bottom. Today, we're using Gilson 8-inch ASTM E11 stainless steel compliance grade test sieves. Place the sieve stack onto a sieve pan. Now place the test sample onto the top sieve and then cap the sieve stack with a sieve cover. Agitate the sieves by means of a mechanical sieving apparatus for a sufficient period of time so that not more than 1% by mass of the material retained on any individual sieve will pass that sieve during 1 minute of continuous sieving. For this demonstration, we are using the Gilson SS15 mechanical sieve shaker. The SS15 delivers superior accuracy and repeatability for particle separations by combining a back and forth lateral motion with an up and down and tilting motion, which causes test material to travel in an orbital direction on the sieve surface. Once sieving has completed its course, measure and record the mass weight of each sample size increment on a scale or balance to the nearest 0.1 gram. Repeat this process for each sieve and the sieve pan. The total mass of the sieve sample should match closely with the original mass of the test sample before sieving. If the amount differs by more than 0.3% based on the original dry sample mass, then the results should not be used and the test should be repeated. In recording the mass of each sample size and determining the gross test sample mass, you should include the total percentage of material passing each sieve and/or the mass of the material retained on each test sieve and pan and/or the percentage of material retained passing consecutive sieves. Now you have all the information needed to determine the particle size distribution of the test sample, and in doing so, determine the particle size distribution of the bulk sample for aggregate uses and mixtures. For any questions concerning dry sieving samples or for any Gilson product, please contact the Gilson Technical Support Team.
For the next method, ASTM C117, test method for materials finer than 75 micrometers, number 200 sieve in mineral aggregates by washing. This method covers the determination of the amount of material finer than a 75 micrometer number 200 sieve in aggregate by washing. Clay particles and other aggregate particles that are dispersed by the wash water as well as water-soluble materials will be removed from the aggregate during this test. Conducting this test is very important. Why? Because it can avoid low compressive strength, decrease durability, which is important, and pop out with the dust-coated particles that exist in the concrete. So, I will present this video for you to be more accustomed with this method. So for the next method, ASTM C40, test method for organic impurities in fine aggregate concrete. This method covers two procedures for an approximate determination of the presence of injurious organic impurities in fine aggregates that are to be used in hydraulic cement, mortar, or concrete. One procedure uses a standard color solution and the other uses a glass color standard. This test method is used in making a preliminary determination of the acceptability of fine aggregates with respect to the requirements of a specification C33 or C33M that relate to organic impurities. So, the principal value of this test method is to furnish a warning that injurious amount of organic impurities may be present. When a sample subjected to this test produces a color darker than the standard color, it is advisable to perform the test for the effect of organic impurities on the strength of mortar in accordance with test method C87 or C87M that I will discuss later on. So here's another video for the procedure of this method.
AASHTO T21 and ASTM C40 are the standard method of test for organic impurities in fine aggregate for concrete. This test method involves the use of hazardous materials. Some of the materials you may encounter performing this test are 3% sodium hydroxide solution, potassium dichromate, and concentrated sulfuric acid. The user of these materials are responsible for their proper use. The principal reason for this test is to determine if there are harmful amounts of organic matter present in the fine aggregate. There are two ways to perform this test. The first is using 3% sodium hydroxide solution and the glass color standard. The other is to produce a standard color solution by dissolving reagent-grade potassium dichromate in concentrated sulfuric acid at a rate of 0.25 grams per 100 milliliters of acid. When using this method, the reference standard color solution must be prepared no longer than 2 hours ahead of time. When using the 3% sodium hydroxide solution method, this is not necessary. To perform this test, we'll need a colorless glass bottle with a capacity of 240 to 470 milliliters, or 8 to 16 fluid ounces. The bottle must have a watertight cap and must have a thickness of at least 1.5 but not more than 2.5 inches. We'll also need the standard color solution or the 3% sodium hydroxide solution and the glass color standard. Let's now review the steps of this procedure using the 3% sodium hydroxide solution and the glass color standard. First, we want to obtain a sample in accordance with AASHTO T2 or ASTM D75 and ensure that that sample weighs approximately 450 grams or 1 pound. We can now introduce the sample into our colorless glass bottle, filling the bottle to the 130 ml or 4.5 ounce level. After adding the sample, add the 3% sodium hydroxide solution, ensuring that the liquid level has been brought to the 200 ml or 7 ounce calibration mark. We now want to cap the bottle and shake vigorously. We must now let the sample sit for 24 hours. And finally, make our color comparison to the glass color standard. If the liquid has produced a color darker than the number 3 glass color standard, or darker than the standard color solution, additional tests may be necessary, such as AASHTO T71, effect of organic impurities in fine aggregate on strength of mortar. Lastly, there are no significant differences between AASHTO T21 and ASTM C40. This will conclude AASHTO T21 and ASTM C40, organic impurities in fine aggregate for concrete.
Next method is ASTM C87 test method for effect of organic impurities in fine aggregate on strength of mortar. This test method covers the determination of the effect on mortar strength of the organic impurities in fine aggregate whose presence is indicated using test method C40. So, ito na nga yung sinasabi ko kanina na yung previous test natin na C40 nag-result ng color darker than the standard color. It is advisable to perform the test for the effect of organic impurities on the strength of mortar, which is this method. So, bakit natin pina-perform tong test na to? What is the importance of it? This test method is a significance in making a final determination of the acceptability of fine aggregates with respect to the requirements of specification C33 concerning organic impurities. C33 will also be discussed later. Sadly, wala akong nakitang video procedure sa method na to, so let's proceed to the next method. Next method is ASTM C88 test method for soundness of aggregates by use of sodium sulfate or magnesium sulfate. This test method covers the testing of aggregates to estimate their soundness when subjected to weathering action in concrete or other applications. This is accomplished by repeated immersion in saturated solutions of sodium or magnesium sulfate, followed by oven drying to partially or completely dehydrate the salt precipitated in permeable pore spaces. The internal expansive force derived from the rehydration of the salt upon re-immersion simulates the expansion of water on freezing. So this method provides a procedure for making a preliminary estimate of the soundness of aggregates for use in concrete and other purposes. The values obtained will be compared with specifications, for example, a specification C33 or C33M that are designed to indicate the stability of aggregate proposed for use. Since the precision of this test method is, it may not be suitable for outright rejection of aggregates without confirmation from the test more closely related to the specific service intended. So again, for the procedure, I will present a short video clip for us to be more familiar with this method.
साउंडनेस टेस्ट एग्रीगेट्स की साल्ट्स के अगेंस्ट रेजिस्टेंस चेक करने के लिए किया जाता है। बिस्मिल्लाहिर्रहमानिर्रहीम। साउंडनेस टेस्ट ऑफ हैरो सैंड या साउंडनेस टेस्ट ऑफ सैंड के लिए जो हमें अपरेटस रिक्वायर्ड होगा, उसमें हमें सैंड का सैंपल चाहिए होगा, स्कूप होगा, उसके बाद सोडियम सल्फेट कंटेनर जिसके अंदर हम सोडियम सल्फेट का वेट करेंगे, स्पून, 1 लीटर हमें डिस्टिल्ड वाटर चाहिए होगा। उसके बाद स्टैंडर्ड के मुताबिक जो हमें सीव चाहिए होंगी, वो सबसे पहली सीव है 9.5 mm, जिसको हम 3/8 की सीव कहते हैं। उसके बाद नंबर 4 की सीव है, उसके बाद नंबर 8 की सीव है, नंबर 16, 30 नंबर और 50 नंबर की सीव है। इसके साथ हमें पेन रिक्वायर्ड होंगे जिनके अंदर हम सैंपल को डिप करेंगे, और उसके बाद वेट वाशिंग सीव रिक्वायर्ड होगी जिसके अंदर हम सैंपल को वॉश करेंगे। इसके साथ साथ हमें बैलेंस रिक्वायर्ड होगा, और लास्ट में सैंपल को ड्राई करने के लिए ओवन रिक्वायर्ड होगा। अब हम सबसे पहले स्टेप में ये जो हमारे पास सैंड का सैंपल है, इस सारे सैंपल को हम इन सीव्स में से पास करेंगे, और हर सीव की पासिंग और रिटेन, इस सीव का पास होगा, इस पे रिटेन होगा, वो हमें 100 ग्राम चाहिए होगा। फिर उसके बाद 4 नंबर की सीव का पास होगा, 8 पे रिटेन होगा, वो हमें 100 ग्राम चाहिए होगा। उसके बाद 8 से 16 का 100 ग्राम होगा, 16 से 30 का, और 30 से 50 का जो रिटेन है वो 100 ग्राम होगा। अब हम इस सारे सैंपल को इन सीव के अंदर डाल के इनको शेक करके 100 ग्राम सैंपल कलेक्ट करेंगे। अब हमने सैंपल को सीव कर लिया है। ये देखें, सबसे पहले हमारी जो सीव है 3/8 से नंबर 4 की सीव है। ये देखें, नंबर 4 3/8, इसका हमें 100 ग्राम चाहिए होगा सैंपल। ये देखें 3/8 से नंबर 4। अब हम इसका वेट कर लेते हैं। 3/8 से नंबर 4 का 100 ग्राम सैंपल। ये देखें, हमने 100 ग्राम सैंपल का वेट कर लिया है, जो कि हमारे पास 3/8 से नंबर 4 की सीव का है। इसी तरह हम तमाम एग्रीगेट्स का जो है वो वेट कर लेंगे 100 ग्राम्स। लेकिन आपने इसमें एक चीज़ का ख्याल रखना है कि ये जो आपके पास सैंपल है, ये वाटर से आपने वॉश करके लेना है। ये सारा सैंपल जो है वाटर से वॉश होगा, ताकि इसके जो पार्टिकल्स के ऊपर डस्ट लगी हुई है वो ख़त्म हो जाए। ये देखें, हमने तमाम फ्रैक्शंस, मतलब पांचों फ्रैक्शंस हमने तैयार कर ली हैं। 3/8 से नंबर 4 100 ग्राम है, उसके बाद नंबर 4 से 8 100 ग्राम है, उसके बाद 8 से 16 100 ग्राम है, उसके बाद 16 से 30 100 ग्राम है, उसके बाद 30 से 50 100 ग्राम है। ये सारे हमने 100 ग्राम सैंपल का वेट कर लिया है। अब हम इधर आते हैं सोडियम सल्फेट की तरफ। इसका हम सोल्यूशन बनाएंगे। सोडियम सल्फेट का जो सोल्यूशन है उसमें 215 ग्राम पर लीटर हम सोडियम सल्फेट डालते हैं वाटर के अंदर। मतलब ये 215 ग्राम वेट करके इस वाटर के अंदर डाल के इसका सोल्यूशन बनाएंगे। अगर इसकी जगह पे आपके पास मैग्नीशियम सल्फेट अवेलेबल है तो वो 350 ग्राम है पर लीटर। तो अब हम सोडियम सल्फेट का सोल्यूशन बनाएंगे। सोडियम सल्फेट का, अब ये जो सोडियम सल्फेट का हमारे पास ये वेट है 215 ग्राम, ये सारा हमने इसके अंदर मिक्स करना है। ये हमारे पास 1 लीटर वाटर है। 1 लीटर वाटर के अंदर 215 ग्राम्स हमने सोडियम सल्फेट मिक्स करना है। उसके लिए आपने ये थोड़ा सा पानी पहले इस बॉटल के अंदर डाल देना है। उसके बाद आपने साथ साथ इसको शेक भी करते रहना है और थोड़ा थोड़ा इसके अंदर साल्ट्स भी डालते रहना है। अगर आप एक ही दफ़ा में सारा साल्ट इसके अंदर डाल देंगे तो वो उसके लम्प्स बन जाएंगे, वो सही से मिक्स नहीं होगा। इसलिए आपने थोड़ा थोड़ा इसके अंदर साल्ट्स डालते जाना है और इसको इस तरह से शेक करते जाना है। अब ये देखें, हमने सोडियम सल्फेट जो है वो सारा इसके अंदर, ये हमने सारा सोडियम सल्फेट जो है इसके अंदर अच्छी तरह से मिक्स कर लिया है इस वाटर के अंदर। अब हम सारे इस पानी को इकट्ठा मिक्स कर लेंगे। ये हमने सारा जो सोडियम सल्फेट का सोल्यूशन है 1 लीटर वो हमने तैयार कर लिया है। सोडियम सल्फेट का सोल्यूशन जो है वो तैयार हो चुका है। अब सोडियम सल्फेट के सोल्यूशन में तमाम सैंपल्स को हम डिप करेंगे और सैंपल के ऊपर जो इसका डेप कवर है सोडियम सल्फेट के सोल्यूशन का वो 1/2 इंचेस से ऊपर होना चाहिए। तमाम सैंपल्स को हम इसी तरह से डेप कर देंगे। 1/2 इंचेस जो है वो इसके ऊपर होना चाहिए, ताकि अगर सोल्यूशन का जो पानी है वो एवेपोरेट होता है तो उस सूरत में ये ड्राई न रह जाएं। 16 से 18 घंटे हम इसको डिप कर देंगे। अब 16 से 18 घंटे के लिए हम इन तमाम सैंपल्स को सोडियम सल्फेट के सोल्यूशन के अंदर डिप कर देंगे। ये देखें, हमने तमाम सैंपल जो हैं वो डिप कर लिए हैं। ये देखें, 16 से 18 घंटे गुजरने के बाद अब हम इन तमाम सैंपल्स का जो सोल्यूशन है वो ड्रेन करेंगे। उसके लिए ये हमारे पास वेट वाशिंग सीव है, 200 नंबर की वेट वाशिंग सीव है, जिसमें से हम इस सारे सोल्यूशन को ड्रेन कर देंगे। ये अच्छी तरह से इसका जो वाटर है वो आपने ड्रेन कर लेना है। बिल्कुल इसी तरह से तमाम हमारे जितने भी सोल्यूशन हैं उन तमाम का इसी तरह से हम सोल्यूशन ड्रेन करेंगे। और उसके बाद इसी वेट वाशिंग सीव में से जो सैंपल है वो बाहर निकाल लेंगे। कोशिश करेंगे अच्छी तरह से जितना हो सकता है उसमें से निकाल लें। अगर इसके अंदर आपको नज़र आ रहा है जिस तरह से ये वाटर अगर नज़र आ रहा है तो आपने इसको दोबारा से ड्रेन कर देना है। और जब तक इसमें से अच्छी तरह से वाटर ड्रेन नहीं हो जाता तब तक आपने इसको ड्रेन करते रहना है। बेहतर ये है कि आप इसको 8 से 10 मिनट के लिए छोड़ दें ताकि इसमें से जो वाटर है वो ड्रेन हो जाए। तमाम सैंपल्स का हमने सोल्यूशन जो है वो ड्रेन कर दिया है। सोल्यूशंस ड्रेन करने के बाद अब हम इन तमाम सैंपल्स को 110 डिग्री सेंटीग्रेड पे 4 से 6 घंटे के लिए ओवन में रख देंगे। यहाँ से आपने ओवन का टेम्परेचर 110 डिग्री सेंटीग्रेड सेट करके यहाँ से सेट करके आपने 110 डिग्री सेंटीग्रेड पे तमाम सैंपल्स को ओवन में रख देना है। अब हम इसको 4 से 6 घंटे के लिए तमाम सैंपल्स को ओवन में रखने लगे। पहला साइकिल कंप्लीट करने के लिए हमने 16 से 18 घंटे के लिए इसको डिप किया था। उसके बाद हमने इसको ओवन में रखा था 4 से 6 घंटे के लिए। 4 से 6 घंटे ओवन में रखने के बाद अब हमने इसको ओवन से निकाल लिया है। अब हम इसको 2 से 4 घंटे के लिए रूम टेम्परेचर पर रख देंगे ताकि इसका टेम्परेचर जो है वो कूल हो जाए। 2 से 4 घंटे के बाद जब इसका टेम्परेचर कूल हो जाएगा उसके बाद उसी तरह से दोबारा हम दूसरे साइकिल के लिए ये जो हमारे पास सोडियम सल्फेट का सोल्यूशन है दोबारा से हम इसके अंदर फिल करेंगे। दोबारा से 16 से 18 घंटे के लिए इसको रख देंगे। इसी तरह से हम इसके 5 साइकिल कंप्लीट करेंगे। हमने इसको फाइनली वाटर के साथ वॉश करना है। ये जो हमारे पास 5 सैंपल्स हैं इन पांचों को हमने वाटर के साथ वॉश करना है, जिसके लिए वाटर का जो टेम्परेचर है वो 43 डिग्री सेंटीग्रेड होना चाहिए। उसके लिए वॉश करने के लिए हम ये वेट वाशिंग सीव नंबर 200 जो है वो यूज़ करेंगे। ये देखें हम 1 बाई 1 तमाम सैंपल्स को वेट वाशिंग सीव के अंदर डालेंगे। सैंपल को डालने के बाद ये वाटर है जिसका टेम्परेचर हमने 43 डिग्री मेंटेन किया हुआ है। अब हम इसके अंदर जो है इसको वॉश करेंगे। वॉश करने के बाद ये सारा सैंपल जो है हम 1 बाई 1 सारे सैंपल इन पैन्स के अंदर निकाल लेंगे और उनको ओवन में ड्राई होने के लिए 18 से 24 घंटे के लिए रख देंगे। ये हमने तमाम सैंपल्स को वॉश कर लिया है, अच्छी तरह से हमने इनको वॉश कर लिया है। अब हम इसको ओवन के अंदर 18 से 24 घंटे के लिए ड्राई करेंगे। ओवन का टेम्परेचर 110 डिग्री सेंटीग्रेड सेट करके अब हमने तमाम सैंपल्स को जो है वो ओवन के अंदर प्लेस कर दिया है। ये देखें हमने तमाम सैंपल्स को ओवन के अंदर प्लेस कर दिया है। अब हम 18 से 24 घंटे वेट करेंगे। जब ये ड्राई हो जाएगा सैंपल तो उसके बाद हम इसको कूल करके इन तमाम के लॉस चेक करेंगे। ओवन से बाहर निकाल लिया है। ओवन से बाहर निकालने के बाद अब हम इसको कूल होने के लिए 2 घंटे से 4 घंटे के लिए हम इसको रूम टेम्परेचर पर रख देंगे। 2 से 4 घंटे के बाद जब सैंपल हमारा कूल हो गया है उसके बाद अब हम इसका लॉस चेक करेंगे। लॉस चेक करने के लिए जो इसकी लास्ट वाली सीव होगी ना, जो भी फ्रैक्शन दी गई होगी 3/8 से नंबर 4 है ना, तो अब नंबर 4 की सीव में से इसको पास करेंगे। ये हमारे पास नंबर 4 की सीव है। ये देखें ये नंबर 4 की सीव है। अब हम इसको नंबर 4 की सीव में से पास करेंगे। इसको आपने अच्छी तरह से शेक कर लेना है। शेक करने के बाद जो इसमें से पासिंग होगी वो इसका लॉस होगा। फॉर एग्जांपल ये पार्टिकल जो है इसमें से पास आउट हो गए, तो उसके बाद जो हमारे पास रिटेन वेट होगा हम इसका वेट कर लेंगे तो हमारे पास होगा ये, और जो वॉश हो गया है उसका वेट आ जाएगा। ये देखिए हमने पहली फ्रैक्शन को जो है सीव में से 4 नंबर की सीव में से पास किया है, जिसका वेट हमारे पास 97 ग्राम्स आया है, जो कि मैंने यहाँ पे पेज के ऊपर भी लिख दिया है कि 3/8 से नंबर 4 की जो सीव थी 100 ग्राम हमारा इनिशियल वेट था। उसके बाद रिटेन वेट जो है 4 नंबर की सीव पे वो 97 ग्राम आया, तो इससे लॉस वेट जो है वो 3 ग्राम्स आया। इसी तरह हम तमाम फ्रैक्शंस को जो है वो सीव्स में से पास कर लेंगे। ये जो हमारे पास 8 to 16 है, इसको हम 16 नंबर की सीव से पास करेंगे, इसको हम 30 नंबर की सीव से पास करेंगे, उसके बाद इसको हम 8 नंबर की सीव से पास करेंगे और इसको 50 नंबर की सीव से पास करके इसका लॉस चेक कर लेंगे। ये देखें हमारी जो नेक्स्ट फ्रैक्शन है वो 4 से 8 100 ग्राम था, उसको हमने पास किया है, ये आप देखें ये 8 नंबर की सीव से। तो अब हम इसके ऊपर जो रिटेन आया है उसका हम वेट करेंगे, उससे जो है हमारे लॉस एग्रीगेट्स आ जाएंगे, यानी कि लॉस जितना सैंड लॉस हुई है उसका वेट आ जाएगा। ये देखें 96 ग्राम जो है वो इस सीव का रिटेन आ गया हमारे पास। ये देखें हमने तमाम फ्रैक्शंस के जो रिटेन वेट हैं वो कर लिए हैं। जो 4 नंबर की सीव पे रिटेन आया था वो 97 ग्राम्स आया था, लॉस 3 ग्राम्स है। उसके बाद नेक्स्ट हमारा 4 से 8 का जो फ्रैक्शन थी 8 नंबर पे हमारा जो आया है रिटेन वेट वो 96 ग्राम्स है। उसके बाद इसी तरह से जो हमारा नेक्स्ट है 8 to 16, उसके 16 पे जो रिटेन आया वो 96 है, 96.5 है, तो लॉस इसका 3.5 है। उसके बाद जो हमारे पास नेक्स्ट है वो हमारे पास 30 पे जो रिटेन आया वो 97.5 है। उसके बाद जो लास्ट हमारे पास फ्रैक्शन थी 30 से 50 वाली, उस पर जो 50 पे रिटेन आया वो 98 है और लास्ट हमारे पास 2 ग्राम्स आया है। तो अब हम इसकी फाइनल कैलकुलेशन की तरफ चलते हैं।
साउंडनेस टेस्ट फॉर फाइन एग्रीगेट की जो कैलकुलेशन है वो बिल्कुल ही आसान है। इसमें ये देखें सबसे पहले हमने तमाम फ्रैक्शंस का 100 ग्राम्स वेट किया था, जिस तरह से मैंने स्टार्ट में बता दिया था अकॉर्डिंग टू ASTM। और उसके बाद 100 ग्राम्स के बाद जब हमने रिटेन वेट लिया हर एक फ्रैक्शन का लास्ट वाली सीव पे, मतलब हमारी जो पहली फ्रैक्शन थी वो 3/8 से नंबर 4 तक थी, तो हमने नंबर 4 पे उसका रिटेन परसेंटेज लिया तो ये 97 ग्राम्स आया। इसी तरह से 4 to 8 नंबर पे हमने लिया तो वो 96 ग्राम्स आया। इसी तरह से हमने तमाम सीव्स के रिटेन वेट ले लिए। उसके बाद उन्हीं रिटेन वेट की मदद से हमने लॉस वेट निकाल लिए, लॉस वेट फ्रॉम सीव नंबर 4, क्योंकि हमारी जो पहली फ्रैक्शन थी वो थी हमारे पास, आप ये देख सकते हैं 3/8 से नंबर 4 थी, तो हमने उसका जो लॉस वेट किया है वो 4 नंबर की सीव पे किया है क्योंकि हमारे ASTM के अकॉर्डिंग, तो वो हमारा आया है 3 ग्राम्स। उसके बाद ये किस तरह होगा, टोटल वेट में से 97 यानी कि रिटेन वेट जो होगा वो माइनस करेंगे तो ये हमारे पास ये लॉस वेट आएगा। इसी तरह हमने तमाम लॉस वेट निकाल लिए, मतलब टोटल वेट से हमने ये रिटेन वेट माइनस किया तो ये लॉस वेट आ गए। उसके बाद हमने जब एक्चुअल लॉस की परसेंटेज या साउंडनेस वैल्यू निकाली तो वो हमारे पास हर एक फ्रैक्शन की हमने उसी तरह से निकाल ली कि जितना जितना लॉस वेट आ रहा था वो डिवाइडेड बाय टोटल वेट ऑफ फ्रैक्शन और मल्टीप्लाई बाय 100 किया तो हमारे पास ये हर एक सीव का लॉस परसेंटेज आ गई। तो ये हमारे पास एक्चुअल लॉस परसेंटेज है या साउंडनेस वैल्यू है हर एक साइज की। तो ये बिल्कुल ही सिंपल सी कैलकुलेशन थी।
So for the next method is ASTM CE142. Test method for clay lumps and friable particles in aggregates. There are 2 test methods for determining the clay lumps and friable particles in aggregates. There is a method for coarse aggregate and one for fine aggregate. The test methods are kind of similar, but there are differences. So this test method is also primarily significant in determining the acceptability of aggregates with respect to the requirements of specification C33. So again, I will present this video for you to be more accustomed with this method.
अस्सलाम वालेकुम जी, आज हमारा टेस्ट है क्ले लम्प्स एंड फ्राइबल पार्टिकल्स C142। इसमें हमारे पास जो मटेरियल है 5 mm का मटेरियल है। तो 5 mm के मटेरियल के ऊपर हम लोगों ने सबसे पहले इस मटेरियल को जो है वॉश किया। 100 ग्राम हमने लिया था, इसको वॉश करके इसके ऊपर हमने स्टैंडर्ड के मुताबिक जो सीव लगाई है वो 20 नंबर की 20 नंबर की सीव लगाएंगे और उस पर जो भी रिटेन आएगा उसका हम वेट कर लेंगे। इसके लिए जो सीवें हैं वो आपको जो सीवें हैं मटेरियल के हिसाब से आपको ASTM C142 में देखेंगे आपको कौन कौन से साइज़ का मटेरियल है वो रिटेन निकालना है। इसका अब हमने रिटेन का वेट करेंगे। इसका वेट आया है 98 हमने इसका वेट यहाँ लिख लिया है। ये इसका बिफोर वॉश था 100 ग्राम और सीव हमारी थी 4 नंबर का पास और 16 का रिटेन, ठीक है। 5 mm का मटेरियल था। 100 ग्राम का जो अभी रिटेन आया है वो 98 यानी 2 ग्राम इसमें से लॉस हुआ। यहाँ पे इसकी परसेंटेज निकाल ली जाएगी तो उसके बाद इसका रिज़ल्ट आ जाएगा, यानी कि इसमें जो क्ले पार्टिकल थे 2 ग्राम थे। इसी तरह हमारा दूसरा मटेरियल था जो कि 3x8 का है। इसका हमने 3 साइज़ लिए हुए थे, 3x8 का पास, 3x8 का रिटेन, 3x4 का पास, 3x8 का रिटेन, 3x8 का पास, 4 नंबर का रिटेन और 4 का पास, 16 का रिटेन। पहला जो वेट है वो 2 किलो लिया, दूसरा 1 किलो, तीसरा 100 ग्राम। जो 3x4 और 3x8 का पास है उसमें हमने रिटेन है, उस पर हमने 4 नंबर की सीव लगानी है, जैसा कि लिखा हुआ है 4 नंबर की सीव का रिटेन चाहिए होगा। इसके ऊपर हम 8 नंबर की सीव लगाएंगे और यहाँ पे हम 20 नंबर की सीव लगाएंगे। अभी जैसा कि देख रहे हैं हम लोग ये 20 नंबर की सीव लगा रहे हैं। जो इसका रिटेन है वो हमें चाहिए कि रिटेन कितना आ रहा है, इससे हमें परसेंटेज पता चलेगी। इसका जैसे कि देख रहे हैं आप वेट आया 98 यानी 2 ग्राम इसमें लॉस हुआ है। दूसरा हमारा जो मटेरियल है वो है हमारा 3x4 का पास, 3x8 का रिटेन। इसके ऊपर हम 4 नंबर की सीव लगा रहे हैं और 4 नंबर की सीव लगाने के बाद जो भी इसका रिटेन है वो हमने निकाल लिया है। इसका जो वेट आया वो 1989 यानी 11 ग्राम लॉस हुआ इसमें से, ये हमने लिख लिया। इसी तरीके से हमारा ये तीसरा मटेरियल ये अभी ड्राई नहीं हुआ है इसलिए हमने इसका भी नहीं किया। ये जैसे ये तीनों वेट आ जाएंगे इनका परसेंटेज निकाल के और एवरेज यहाँ पे लिख ली जाएगी। तो हमारे पास 3x8 जो हमारा साइज़ है उसके ऊपर क्या लॉस क्ले लम्प्स एंड फ्राइबल पार्टिकल्स कितने आए हैं वो परसेंटेज पता चलेगी। तो ये हमारा क्ले लम्प्स का टेस्ट है। ये कंक्रीट में यूज़ होने वाला एग्रीगेट है। इसमें हमें सिर्फ मालूम करना होता है कि इसमें क्ले लम्प्स और फ्राइबल पार्टिकल्स कितने हैं। तो जो भी है इसकी रिक्वायरमेंट है इसकी अकॉर्डिंग टू स्पेसिफिकेशन 1% होनी चाहिए, 1% से ज़्यादा नहीं होना चाहिए।
So that's all my part. For the continuation of quality test on aggregates, here is Leomar Mangapat.
So thank you, Miss Kyla Romanos, for that wonderful report. So, hi, my name is Leomar Mangopot, and I'm gonna discuss the part 2 of ASTM Standard Quality Test on Aggregates. So, let's start. So, dito sa slide na to ay tungkol sa coal and lignite, aggregate, then yung ASTM test na connected dito ay ASTM C123 test method for lightweight particles in aggregates. So, kapag kumukuha tayo ng desired aggregates natin sa isang lugar, especially coal and lignite, hindi talaga natin may iwasan na may mapahalong different types ng aggregate. Example nito is yung mga porous aggregate which can absorb water. So, malaking effect yon sa mga concrete natin. So, nagraran tayo ng different test para ma-determine natin kung gaano ba kalaking percentage yung meron o napapahalo sa mga aggregates natin. Etong ASTM C123 quality test, ang purpose niya ay nabibigay siya ng data para malaman natin kung gaano karaming lightweight particles meron sa ating aggregate. So, kumukuha tayo ng sample para sa test, then lalagyan natin siya ng zinc chloride. Pagkatapos nun, hahaluin natin siya para mag-float yung mga lightweight particles. Then, isa-separate natin at papatuyuin natin yung lightweight particles para ma-determine natin kung gaano ba siya karami. So, we will show you a video procedure on how test method in lightweight particles are done.
First, obtain your sample. We typically use a sample that has been washed. This is a sample of number 4 aggregate. The material passes through the number 4 sieve and is retained on the number 30. Introduce the sample into a suitable container, making sure you do not lose any material. Cover the sample with the zinc chloride solution 3 times the volume of the aggregate. Stir the sample for approximately 15 seconds. Then, let sit for 30 seconds, allowing the lightweight particles to float to the top in a defining line between the heavier aggregate and the lightweight aggregate. Carefully decant off the floating pieces over a number 30 sieve. Do not include any of the heavier particles on the bottom of the sample. Repeat this process a maximum of 3 times. Be careful not to include the heavier particles from the bottom of the sample each time. Use hot water and minimal water pressure to remove the zinc chloride from the lightweight pieces on the sieve. This is a picture of a -4 lightweight pieces sample. Wash the particles into an oven or drying safe container. Decant excess water. Dry to constant weight and record.
Next naman po is about sa bulk density of slag at yung ASTM na nakadesignated dito ay ASTM C29 test method for bulk density and voids in aggregate. So, this test method is often used to determine bulk density values that are necessary for use for many methods of selecting proportions for concrete mixtures. The bulk density also may be used for determining mass-volume relationship for conversions in per-case agreements. A procedure is included for computing the percentage of voids between the aggregate particles based on the bulk density determined by this test method. Yung bulk density kasi or unit weight ng aggregate ay yung mass or weight niya na kailangan para mapuno yung isang container na may specific unit volume. Kung alam natin yung bulk density ng isang material, madali na rin natin ma-determine yung mass or weight na kailangan para ma-fill yung unit volume ng isang container. Mahalaga ang pag-determine ng bulk density ng isang aggregate para malaman natin yung percentage ng voids na present. Yung voids, yun yung mga makikita nating spaces or butas sa isang material. Importante kasi yun dahil malaking epekto yung mga voids o butas sa pagpapatibay ng concrete natin. At saka mahalaga din yung bulk density para sa compact ng isang concrete. Yung walang masyadong hangin yung concrete natin. So, may ipe-present po kaming video procedure para sa test method for bulk density and voids in aggregate. Next naman po is about abrasion of coarse aggregates. Yung ASTM standards na nakadesignated dito ay ASTM CE31, test method for resistance to degradation of small size coarse aggregate by abrasion and impact test in the Los Angeles machine. So this test is a measure of degradation of mineral aggregates of standard gradings resulting from a combination of actions including abrasion or attration, impact and grinding in a rotating steel drum containing a specified number of steel spears. The number depending upon the grading test sampled. As the drum rotates, a shell plate picks up the sample of the steel spears, carrying them around until they are dropped to the opposite side of the drum, creating an impact crushing effect. The contents then roll within the drum with an abrading and grinding action until the shield plate picks up the sample and the steel spears and the cycle is repeated. So yung test na ito is para ma-determine natin yung abrasive value ng aggregate material na kaya mag-withstand sa impact na gagawin ng test na ito. Mapapakita nito kung gaano kaya i-resist ng coarse aggregate yung abrasion at malalaman natin yung hardness ng material. Mahalaga tong test na to para sa mga aggregates na ginagamit natin, especially sa mga highways, para ma-resist nila yung bigat ng mga sasakyan at sa mga infrastructure para ma-resist nila yung mga loads. So, we will present a video procedure on how ASTM CE131 test is being demonstrated. Sunod na slide is about reactive aggregates, and yung ASTM standard na designated dito is Appendix X1 of ASTM C33 or C33M, methods for evaluating potential deleterious expansion due to alkali reactivity of an aggregate. So based sa Appendix X1 3.3.4, test method C1260 mortar bar method for potential alkali reactivity of an aggregate. This test method is an accelerated screening technique developed for the detection of materials that develop deleterious expansion slowly over a long period of time. Some aggregates that perform well in the field have been shown to fail this test. Results of this test method should not be used for rejection of aggregates unless it has been established using the sources of supplementary information cited in the test method that the detected expansion is actually due to alkali-silica reaction. So, yung makikita nyo sa image is may mga crack siya na nangyayari sa mga concrete due to alkali-silica reaction. So, common na nangyayari yan sa mga concrete natin. Pag nagtagal, nagkakaroon sila ng mga pagbitak na may kulay. So, nalalaman natin yung expansion o pagkalat ng alkali-silica reaction sa mga concrete pag nagtagal gamit yung test na ito. So, we will present you a video procedure on how test method CENG60 mortar bar method for potential alkali reactivity of an aggregate is being demonstrated.
Master Builder Solutions.
Next naman po is about freezing and thawing, and yung ASTM test na designated dito ay ASTM C666 or C666M test method for resistance of concrete to rapid freezing and thawing. So, this test method covers the determination of the resistance of concrete specimens to rapidly repeating cycles of freezing and thawing in the laboratory by two different procedures. Procedure A, rapid freezing and thawing in water, and Procedure B, rapid freezing in air and thawing in water. Both procedures are intended for use in determining the effects of variations in the properties of concrete on the resistance of the concrete to the freezing and thawing cycles specified in the particular procedure. Kapag taglamig or tag-ulan, yung mga tubig na pwedeng makapasok sa concrete natin. Then kapag naging frozen siya at natunaw siya sa tag-init, pwede itong magdulot ng mga pressure sa concrete hanggang sa magkaroon ng pagkabitak-bitak. Paulit-ulit yung process hanggang sa mag-expand yung mga crack sa ating mga materials. So, we are using this test to determine natin yung resistance ng ating mga aggregate kapag nagkaroon ng rapid freezing and thawing. Mahalaga itong test na to para masiguro natin na yung mga aggregates na gagamitin natin is kayang mag-resist sa mga climate conditions. So, we have a video procedure on how freezing and thawing are demonstrated.
Master Builder Solutions.
Last naman po is about chart, and yung ASTM test na designated dito ay ASTM C123 again, test method for lightweight particles in aggregate. So, used to identify particles in a sample of coarse aggregate lighter than 2.40 specific gravity. So, heavier liquids are to be used to check the percentages of other lightweight particles such as chert and shale having a specific gravity less than 2.40. The test method is useful in identifying porous aggregate particles in research activities or in petrographic analysis. Yung chert kasi isa siyang type ng porous aggregate na mabilis mag-absorb ng water. So kapag marami yung chert sa isang aggregate, mabilis yung pag-expand ng mga crack sa material natin dahil ito yung dahilan kung bakit nagkakaroon ng alkali-silica reaction. So, ang purpose nitong test na ito, katulad nung unang slide, is para magbigay ng data para malaman natin kung ilang percent ba meron sa sample natin. So, we will show you a different video procedure on how ASTM C123 is being demonstrated. And after that, the next reporter, Jolazan Ramos, will talk about sieve analysis. Thank you for listening.
Good day everyone, I'm Joloshan A. Ramos, who happens to be the last reporter of this group. And today, we are going to discuss about the sieve analysis. So as for the content of our last topic, which is the sieve analysis, first we will mainly discuss on its definition or what is it about. Second is the background information, its origin, components of the test sieves, and the scope and limitations of this analysis. Third are the different methods involved in sieve testing or sieve analysis. And lastly is the application or the practice we use in engineering. And as we begin, first, what is sieve analysis? The sieve analysis, or commonly known as the gradation test, is a basic essential test for all aggregates technician. Sieve analysis determines the gradation in order to determine compliance with the design, production control requirements, and verification specification. Ano nga ba ang gradation? The gradation Yun yung distribution of aggregate particles by size within a given sample. And importante malaman natin yung grading or size distribution of aggregates because it determines the paste requirements for workable concrete. Siya yung nagtuturo sa atin sa tamang sementong ihahalo kasi yung required amount of cement paste is dependent upon the amount of void space that must be filled and the total surface area that must be covered. For example, medyo malaki yung aggregates na gagamitin natin sa isang project. This would result sa concrete to have rough surface which happens to have lots of void spaces which is needed to be covered up by the cement paste. Kaya, importante na malaman yung size distribution to know the required amount of paste that we need to use. Next, the gradation data may be used to calculate relationship between various aggregates or aggregate blends, to check compliance with such blend and predict trends during production by plotting gradation curves graphically, to name just few uses. In addition to use in conjunction with other tests, the sheave analysis is a very good quality control and quality acceptance tool. Ayun nga, matutulungan tayo ng sheave analysis na malaman yung tamang ratio ng semento, graba o buhangin in a specific project for a specific use. Next is the origin. Dito na papasok yung background information about sheave analysis. According to research, it has been found that sheaving began in ancient Egypt to grade grains. Ginagawa ito probably to clean the grains. In this process, all the materials other than the grains are removed. Materials like sand, stones, weeds, yan yung mga yan. Through sheaving, grains could be separated. And as we can see on the left portion of the slide, is a picture of a sheave that is used during the ancient Egyptian times. Throughout its history, sheaving has been deployed in many fields. For example, concrete formulations depending on sheavings and quality control in powder production often depends on sheaving. And isa nga sa example dito ay yung ginagamit natin in the field of civil engineering. There are three main components of test sheaves. First is the frame. It is used to provide space between test sheaves when stuck, allowing the material being tested to move freely. In conducting a sheave analysis kasi, it is not just composed of only one sheaves. It is composed of stacking of sheaves or madaming sheaves na nag-stack up, na may iba't ibang sizes yung mga mesh nila. Since nabanggit ko na nga yung mesh is another part or components of test sheaves. Mesh is the most critical part of any test sheaves. It is used to separate the larger particles from the smaller ones. Generally, stainless steel wires are used to construct the mesh and have a mesh opening that differs in size. The third one is the skirt. It provides support to the stock test sheaves, preventing the stock from topping over when conducting a test sheave analysis. So basically, yung skirts yung nagla-lock up sa mga sheaves from one sheaves to another. As sheaving was introduced to industry after industry, volumes of diverse specifications emerge. Specifications naming frame construction and mesh sizes began to proliferate. There are now stainless steels and brass frames, about 10 different test sheaves, diameters ranging from 35mm to 18 inches and beyond. The measuring media contains several types of woven wire, electroformed openings, and perforated plate. There are over 50 opening of aperture sizes. In addition, there are number of sheave frame depths. And for us to furtherly understand, here is a video that discusses about the different sizes of test sheaves. It is for the visualization or our visualization, and also for us to have an idea of the range of openings of its mesh.
Sieve mesh. What does it look like? Test sieves are used in a variety of industries to determine the distribution of particle sizes in raw materials, processing stages, and finished products. Materials for highway construction are at one end of the requirements. These openings are measured in inches. At the other extreme are pharmaceutical applications that top out at less than 5 microns. In between are just over 50 standard test sieve sizes. The range of openings is achieved by different weave sizes of wire mesh. The largest standard is a mesh with 5-inch openings. That's pretty big. Substantial sized rocks will pass through these openings. To give a perspective on the look of these mesh sizes, we photographed a few, comparing them with common items. Our objective is to give a frame of reference by relating the opening sizes to real-life material. We start with a 50 millimeter or 2-inch sieve using a dollar bill and a pen for reference. We make a jump to 6.3 millimeters or a 1/4 inch, comparing the opening with a couple of quarters. When the hole sizes get smaller, the numbering convention changes to an alternate number starting at 3.5 for a 5.6 millimeter sieve and ending with the number 635 for a 20 micron sieve. Yes, the number increases as the size decreases. By the way, a 20 micron sieve is at the limit of woven wire mesh potential. The producers of gravel for the construction industry use sizes that range from larger openings such as 3 inches to the level of 1/2 inch. Moving on to the soil sampling analysis, soil sampling specifications regularly call for sieve ranges from 2.8 millimeters on number 17 to 1 millimeter on number 18. As the sizes get smaller, for example, a 710 micron, 125 number sieve, a small sewing needle will pass through an opening, but a push tack will not. At the level of a 425 micron sieve, or a number 40, only the point of the needle will fit into the holes in the mesh. Next, we test some sugar using 3 mesh sizes: 355 microns, 250 microns, and 180 microns. We find that all the sugar goes through the number 45 or 355 micron sieve. Some of it passed through the number 60 or 250 micron sieve, while some stayed on the surface. None of the sugar that went through the 60 sieve passed through the holes in the number 80 sieve. These results tell us that sugar particles were all smaller than 355 microns, that some were larger than the 250 microns, and that none were smaller than the 180 microns. So the range of the sugar particles were between 180 microns and 355 microns. I'm sure that many of you are familiar with coffee creamer, the artificial cream for coffee. For our next illustration, we loaded a scoop of creamer on a 120 micron sieve and shook it through. All of it passed. At the next sieve, a 106 micron sieve, most of the creamer passed, with a small amount being retained, some particles larger than a 106 micron, but smaller than 120 micron. At the 75 micron sieve level, almost no creamer passed through, telling us that the remaining creamer consisted of particles larger than 75 microns. Next, we observed a ruler and paper clip behind a 45 micron number 325 sieve. As you can see, there's only a faint shadow. The mesh almost completely stops the light. Sieves with opening sizes less than 45 microns, namely a number 400, 38 micron, a number 450, 32 micron, a number 500, 25 micron, and a number 635, 20 micron sieve usually requires special processes such as vacuum or ultrasonic assists to get effective separation. We hope this short film gives some perspective on the range of opening sizes available for wire mesh test sieves. Please use it for staff training or forward to a colleague. Thank you for watching.
As we move on to the scope and limitations of sieve analysis, first is the scope. A sieve analysis can be performed on any type of non-organic or organic granular materials including sand, crushed rock, clay, granite, feldspar, coal, soil, and a wide range of manufactured powder, grain and seeds down into a minimum size depending on the exact method. Being such a simple technique of particle sizing, it is probably the most common. Kung mapapansin natin, sieve analysis can be mainly performed on aggregates like sand, crushed rock, clay, granite, feldspar, yung mga ganon. Limitations. For material that is finer than 100 mesh, dry sieving can be significantly less accurate. This is because the mechanical energy required to make particles pass through an opening and the surface attraction effects between the particles themselves and between particles and the screen increases as the particle size decreases. So, kung masyadong fine yung material to be tested, di siya gaano magiging accurate kasi magiging factor yung force applied. Since finer materials requires greater force or greater mechanical energy. Kaya di gaano lulusot yung material sa openings ng sieves kasi di enough nga yung force na napro-provide ng dry sieving method which make it less accurate. There are different methods of sieve analysis. The manual sieving method, mechanical sieving method, dry sieving method, and wet sieving method. In manual sieving method, it is carried out in places where there is no electricity and mainly used in on-site differentiation among large and small particles. I know that we are all familiar with this kind of sieving method because this method seems to be the traditional way of sieving here in the Philippines. Mostly in construction sites, kahit sa mga kalsada, sa tabi-tabi, makakakita tayo ng mga taong nag-sieve gamit ang manual sieving method. Even though may electricity naman dito sa Pilipinas, manual sieving method pa rin ang ginagamit nating mga Pilipino because it is economic friendly, it is not costly or expensive, and it does not require machineries that also cost lots of money. Next is the mechanical sieving method. In mechanical sieving method, it can be classified into two further groups depending on their sieving movement, as horizontal movement sieving method and vertical movement sieving method. In this sieving method, unlike the manual sieving method na ang ginagamit natin ay manpower, mechanical sieving method requires machineries na siya na mismo yung gagawa ng vibrations o ng shaking na magkokos sa particles na bumaba from one mesh to another. And just like what I've said, mechanical sieving method is divided into two groups. First is the horizontal movement sieving method, as as its name suggests, is a sheaving method that utilizes purely horizontal mechanical movements. So, nag-shake siya or nagbabibrate siya horizontally. And yung pangalawa naman ay yung vertical movement sheaving method. And as its name suggests ulit, yung during sheaving, the sample is subjected to vertical movements, vertical shaking or vibrations. The next two sheaving methods na mababanggit are the sheaving methods that are commonly used or performed in laboratories. These methods can be either performed manually or through by hand or through machineries or mechanical. Kung sa kanina, yung dalawang sheaving methods which are the manual sheaving methods and mechanical sheaving methods are more specific, ito namang next two ay way more general or naka-generalize sila. Since pwede nga siya i-perform manually or mechanically. And to continue, the dry sheaving method. It is considered mostly and here the testing particles or specimen are in dry state. So basically, yung mga testing materials or materials to be tested ay tuyo or hindi basta. Yun na yun. Lastly is the wet sheaving method. This method is considered when a particle that is going to be used is already exists as wet or suspension. Isa sa evident example ng wet sheaving method dito sa Pilipinas ay yung mapapanood natin sa Eyewitness, wherein yung mga bata at matatanda, yung mga senior citizen and talagang bata pa ay sumisisid sa ilog para kumuha ng clay which are already basa na and sasalain nila yon or i-sheave nila para ma-harvest nila yung gold na hinahanap nila. And for the last topic, for sheave analysis is the application to civil engineering. In here, it suggests that gradation is usually specified for each engineering application it is used for. For example, foundations that might only call for coarse aggregates and therefore an open gradation is needed. Sheave analysis determines the particle size distribution of a given soil sample and hence helps in easily identification of a soil's mechanical properties. These mechanical properties determine whether a given soil can support the proposed engineering structure. It also helps determine what modifications can be applied to the soil and the best way to achieve maximum soil strength. So, katulad ng sinabi sa article, sheave analysis helps in lots of aspects and ways in the field of civil engineering. Magiging malaking tulong talaga ang sheave analysis, especially in the field of construction, since na sheave analysis yung tutulong na mag-analyze ng soil, ng aggregates na gagamitin sa pagtatayo ng foundations, ng building, and ma-analyze din through sheave analysis ang soil kung saan mismo itatayo yung building. And through it, malalaman natin kung kaya ba i-support ng specific soil na yon yung itatayo nating building. And if alam na natin yung approach na gagamitin natin sa specific building or yung mga standards and practices that we are going to use, yung safety ng mga tatao sa building na yon in the future will be ensured. And yun nga, it will be only going to happen if a prior testing is conducted, which is the sheave analysis testing. Since that yung sheave analysis nga is a laboratory work, I'm going to provide a laboratory exercise for us to furtherly understand the procedures and the methods that are used in sheave analysis. So as for the laboratory work in sieve analysis of aggregates, sieve analysis helps to determine the particle size distribution of the coarse and fine aggregates. This is done by sieving the aggregates as per ASTM E11 or the code that we use in the sieve analysis. In this, we use different sieves as standardized by the ASTM code and then pass aggregates through them and thus collect different size particles left over different sieves. And for the apparatus that we must use are first a set of ASTM sieves of sizes of 80 mm, 63 mm, 50 mm, 40 mm, 31.5 mm, and so forth. Second, we need a balance or scale with an accuracy to measure 0.1% of the weight of the test sample. And the weight of the sample available should not be less than the weight given below. After knowing the apparatus that we must use in the analysis, next is the procedure. The procedure to determine the particle size distribution of aggregates. First, the test sample is dried to a constant weight at a temperature of 110 plus 5 degrees Celsius and weighted. Second, the sample is sieved by using a set of ASTM sieves. The third, on completion of sieving, the material on each sieve is weighted. Fourth, cumulative weight passing through each sieve is calculated as a percentage of the total sample weight. And lastly, fineness modulus is obtained by adding cumulative percentage of aggregates retained on a sieve and dividing the sum by 100. To sum up the procedure, first, kailangan daw natin kumuha ng basically tuyong sample. Then yung sample na yon, ilalagay natin siya sa mga standardized na sieves natin because they will undergo the sieving process. And upon sieving, yung mga material na babagsak on each sieves ay i-weight natin. And through that, makakalculate o makukuha natin yung percentage ng total sample weight. And lastly, makukuha natin yung fineness modulus na hinahanap natin. At para maintindihan natin yung example procedure na binigay, I will going to provide also a video presentation that will going to tackle the sieve or methods of sieve analysis and its procedure. Because sieve analysis is mainly on our laboratory work, and I think that the definitions and pictures are not enough for us to furtherly understand. And since na kailangan or essential to sa field of civil engineering, dapat maintindihan natin ito. Kaya here are the videos.
Today, we're going to demonstrate the dry sieving test method used to determine the particle size distribution of fine and coarse aggregates in accordance with ASTM C136, where a sample of dry aggregate of a known mass is separated through a series of sieves with progressively smaller openings to determine the particle size distribution of the test sample. The standard test method for sieve analysis of fine and coarse aggregates is used primarily to determine the grading of materials proposed for use as aggregates, and to determine the compliance of particle size distribution where applicable specifications are required, and to provide necessary data for quality control of production of various aggregate products and mixtures containing aggregates. Devices required for this test method are a balance or scale used in testing of fine and coarse aggregates with a readability of 0.1 grams for fine aggregate and 0.5 grams for coarse aggregate or mixture of fine and coarse aggregates. Test sieves that conform to ASTM E11 specifications. A mechanical sieving device to create motion of the particles to bounce, tumble, or otherwise turn as to present different orientations to the sieving surface. An oven of appropriate size capable of maintaining a uniform temperature of 110 degrees Celsius. A sieve brush, a sample container or pan, a sieve pan, a sieve stack cover, and a way to record and analyze your test findings. It is important to limit the quantity of test materials on any given sieve so that all particles have the opportunity to reach the sieve openings a number of times during sieving operations. For this demonstration, the bulk sample has already been reduced to an amount suitable for testing using the applicable procedures described in ASTM C702. The procedure for standard test method for sieve analysis of fine and coarse aggregates, we first dry the test sample in an oven at a constant temperature of 110 degrees Celsius. Measure on a balance or scale the tare weight or unladen weight of your sample container or pan. Now place the test sample into the sample container and measure its gross weight. Next, select test sieves with suitable openings to furnish enough information required by the specifications covering the material being tested. Nest the sieves in order of decreasing size openings from top to bottom. Today, we're using Gilson 8-inch ASTM E11 stainless steel compliance grade test sieves. Place the sieve stack onto a sieve pan. Now place the test sample onto the top sieve and then cap the sieve stack with a sieve cover. Agitate the sieves by means of a mechanical sieving apparatus for a sufficient period of time so that not more than 1% by mass of the material retained on any individual sieve will pass that sieve during 1 minute of continuous sieving. For this demonstration, we are using the Gilson SS15 mechanical sieve shaker. The SS15 delivers superior accuracy and repeatability for particle separations by combining a back and forth lateral motion with an up and down and tilting motion, which causes test material to travel in an orbital direction on the sieve surface. Once sieving has completed its course, measure and record the mass weight of each sample size increment on a scale or balance to the nearest 0.1 gram. Repeat this process for each sieve and the sieve pan. The total mass of the sieve sample should match closely with the original mass of the test sample before sieving. If the amount differs by more than 0.3% based on the original dry sample mass, then the results should not be used and the test should be repeated. In recording the mass of each sample size and determining the gross test sample mass, you should include the total percentage of material passing each sieve and/or the mass of the material retained on each test sieve and pan and/or the percentage of material retained passing consecutive sieves. Now you have all the information needed to determine the particle size distribution of the test sample, and in doing so, determine the particle size distribution of the bulk sample for aggregate uses and mixtures. Quality control is of utmost importance in construction. During a project, you never want to discover that the aggregate product you're using is ineffective or worse, unsafe. A sieve analysis or gradation test determines the distribution of aggregate particles by size. This information can then be used to determine if the material will comply with design and production requirements. A dry representative sample of material is weighed and then is placed in the top of a group of nested sieves or screen trays, arranged in descending order from the largest openings at the top to the smallest at the bottom. The stack is agitated manually or using a sieve shaker for a designated period of time, and the operator weighs the material retained on each sieve using one of two methods: the cumulative method and the fractional method. For the cumulative method, each sieve fraction, beginning with the coarsest, is placed in a previously tiered pan and weighed. As each retained fraction is added, divide the cumulative mass by the total mass of the sample and then multiply by 100 to calculate the percent retained. Subtract the cumulative percent retained on a given sieve from 100 to calculate the percent passing. For the fractional method, the operator weighs the content of each sieve fraction separately, waiting to discard material until the test is complete. As the operator weighs the content of each sieve fraction, the operator will divide the mass retained on each sieve by the total mass and then multiply by 100 to calculate the percent retained. To calculate the percent passing, the operator subtracts the percent retained on the sieve nested beneath. Depending on the specifications for the materials being tested, the findings should include the following: total percentage of materials passing each sieve, or total percentage of materials retained on each sieve, or percentage of materials retained between consecutive sieves. Follow these tips for accurate and repeatable particle determinations. Avoid overloading sieves. Total material retained on a sieve at completion should be less than 1 to 2 layers deep. Allow enough time on a sieve shaker or testing screen for complete separations. Watch for degradation. Some brittle or friable materials can break apart during separation process, leading to inaccurate results. And regularly check the mesh for wear, tears, or distorted openings, since this can bias test results. Gilson's testing screens are designed for coarse materials of mid-range density, such as limestone or gravel, and Gilson's sieve shakers offer many tabletop options for coarse materials up to 2.
And that's it for the video presentation about chip analysis. I hope that you have understand and gained the basic knowledge about it. And even though we are not in the laboratory and we have not conducted a laboratory exercise, I still hope that you have understand and visualized the process in the chip analysis through the videos that I have been provided. And that's all. Thank you and God bless.